Samy the Alien is playing an instrument on a distant planet, but here's the problem. I want to know exactly what instrument Samy is playing, and I don't have a microphone anywhere near him. All I have is a messy, noisy signal. That's just one of the many different problems this system right here can solve. But before we get into that, hi, my name is Giovanni Orozco. I am a master's student in electrical engineering at Arizona State University. In this video, I will be demonstrating the Digital Downconverter, the FFT and its magnitude in Simulink. I will also be demonstrating spectral averaging in MATLAB. This video is my submission for my SES 598 final project, but hopefully will be useful for any audience wanting to learn more about this subsystem. And I'll be sure to keep us updated on Samy. The first part of the chain is the Digital Downconverter. The purpose of the DDC is simple. We want to isolate Samy in the middle of a chaotic alien concert. Now if we go inside, we can see the different blocks that make up this Digital Downconverter. The first stage is the mixer, here represented by a product block. You can think of this as tuning a directional microphone exactly to Samy's frequency. By multiplying his signal with the local oscillator, here represented by an NCO block, we shift his sound to a frequency where we can focus on it. Next is the low-pass filter. This is like putting soundproof panels around Samy on stage. It blocks out the other aliens and leaves us with the part that sounds like his instrument. Here it is represented by a series of sum, gain, and delay blocks. Just very briefly, here are the NCO parameters and then the low-pass filter parameters. Now that we have Samy's signal isolated with the mixer and the low-pass filter, we can downsample. This allows us to reduce the amount of data we're taking and zero in on Samy's signal. For this demonstration, we will be inputting a chirp signal. This will allow us to view all the frequencies that, in our case, Samy's instrument will make. Inside this digital spectrometer subsystem, we will see our FFT block. This FFT block is what converts Samy's isolated time signal into a frequency signal. Using this, we can see all the different tones that Samy's instrument is producing. This magnitude block shows exactly how strong each frequency is. This essentially turns our weak signal into a stronger one we can analyze a bit easier. The spectral averaging part of the chain is done in MATLAB. You can see the code on screen. Essentially what we are doing here is summing across all the frames that the FFT is running and strengthening the consistent frequency, but also weakening the random ones. In our case, the spectral averaging subsystem is weakening the random alien crown noise and bringing Samy's instrument to the forefront. With the NCO parameters and the low-pass filter parameters from earlier, we can run the Simulink system and see it all work in action. This right here is the raw chirp signal that we are getting from space. This is the DDC working on it, isolating Samy, and the FFT shows Samy's instrument frequency. When we run the averaging system in MATLAB, we are able to see exactly where in the mix Samy is. This top graph right here represents Samy's raw FFT signal, and this bottom one is the average spectrum. So briefly, I just want to talk about what made this whole chain finally click for me. For me, the key was music. When I listened to a chirp and saw how the EQ reacted, it matched everything we are doing in Simulink. Downsampling audio sounded exactly like the DDC, and so did filtering it. Applying the concepts to something that really mattered to me made it all click in my head. What challenged me, however, was skipping steps. I am naturally impatient, and instead of slowing down to try to really understand the material, I would get frustrated at myself and jump ahead. But skipping steps only made the concepts harder and didn't really let it sink in. This project forced me to learn patience, not only with the science, but with myself. Wrapping up right here, I just kind of want to show how this block diagram represents the learning pipeline that was taken in order to understand the signal processing chain. Math was the starting point. This represents the equations and formulas that need to be learned in order to understand the theory behind what we're doing. Algorithm is turning that math into reproducible steps, kind of like a recipe. In this case, that recipe was the Digital Downconverter steps that we designed. Where this video stops is the modeling section. This is everything that we did in Simulink and MATLAB. Hardware is the final step. This chain that we made with the DDC and the FFT and the Magnitude and the Spectral Averaging system all would run on an FPGA. This is what allows us to identify signals in the real world. A little bit more important than Samy's instrument on that alien planet. Okay, so that's the end of this video. Thank you for watching. Press a like if you liked it, share it with someone that you know would like it, and if you made it this far, comment down what instrument you would play if you were an alien.